So welcome to the next chapter. So in this chapter we'll talk about continuous probability distributions. So what are continuous probability distributions? So in the lecture we'll discuss what is a continuous random variable, and we'll see what is a continuous probability distribution, and we'll see probability density function, the properties of these distributions, and one type of distribution called the normal distribution, characteristics of that distribution and the standard normal distribution, and the properties of that normal distribution. So the rest of the topics we'll discuss it in the next lecture. So let's start with the continuous random variable. So a continuous random variable is any variable that can be assumed that there are infinitely many values corresponding to a point on a line interval. So there are not single values, there are infinitely many values. For example, heights, there can be myriad amount of heights. In the same way, birth weights can be an infinite amount, and blood pressure can also be continuous values or generally infinite amounts. Length of life of a medicine is also a continuous amount, where you cannot be sure whether a medicine will work until a certain time only. Even though it shows there is an expiry, the expiry does not say that it does not work. It says what is the effectiveness of the drug. So how do we visualize continuous probability distribution? Suppose we take the measure of heights of students in a class, and if we discretize the values by rounding them to the nearest feet, we notice that you will get this diagram. Now, if you take the same height and you measure it to the nearest inch, you will see that there are much more values. In the same way, when you start going down to the point inches, you will start noticing that we get more bins and much smoother appearance. Imagine that we continue in this way to measure height more and more finely. So the resulting probability histogram appears to be a smooth curve. So because of this reason, we call these distributions continuous probability distributions. So a probability distribution basically describes how probabilities are distributed over all possible values of x. Now a probability distribution for a continuous random variable x is specified by a mathematical function denoted by f of x. And this f of x is called as the density function. So the density function, the graph of the density function generally has to be a smooth curve for it to be a continuous probability distribution. So to represent this continuous probability distribution, we use probability density function. So if you remember from discrete normal distributions, we call it as probability mass function because those are specific values. But here we call this probability density functions because these values have a density function curve between 2 points A and B is equal to the probability that falls between A and B. So the total area under the density function curve over the entire range of possible values of the random variable is always equal to 1. So these are the two main properties. The density function is always greater than or equal to 0, and the total area is always equal to 1. And the probability between 2 points A and B is the area between those 2 points A and B. So this is how we can calculate the values. Now what are the other things? Probability of one single specific value is always nearly equal to 0 because you cannot have a single value when you have a continuous probability distribution. So for any specific value of A, the area will always be equal to 0. Now one way to do this, most common way, is to take less than, but remember that because equal to is A, 0, less than A is the same as x less than or equal to A. In the same way, P of A less than x less than B is the same as A less than or equal to B, x less than or equal to less than B, and all these versions. Because at a specific value there is no probability, so you can write it in different formats. Now one of the common forms of continuous probability distributions that is more commonly used than any other is the normal distribution. So this is the most widely used continuous probability distributions. The other name is Gaussian distribution, known because of the well-known mathematician Carl Friedrich Gauss. So if you see Gaussian distribution or normal distribution, both mean the same. Now what is the normal distribution? So this is the equation that represents the probability density or the density function for the normal distribution equation. So 1 by 2 under root 2 pi in times sigma into e to the power minus of x minus mu square by 2 sigma square. So again, pi is 3.14, e is 2.71, mu represents the mean and sigma represents the standard deviation. Because this formula is complex, what we try to do is we try to standardize this. So before we try to understand standardization, let's discuss the characteristics of a normal distribution. So the first characteristic is that it is symmetrical about its mean. So if you take the mean, it splits the two parts, so it splits it into two equal parts. So this becomes 50% and this becomes 50%. And the curve on either side is a mirror image of the other. So both are mirror images of each other, and the mean, median and mode are all equal. So this is the point where mean is equal to median is equal to mode. Next, the total area under the curve above the x-axis is 1 square unit. So the total area under the curve, so sigma p of x equal to x, or sigma f of x. So we don't use sigma, but the total area is always equal to 1. Next, 4. If you erect two perpendiculars at a distance of 1 standard deviation, so for example, if you take from mu, if you take 1 standard deviation to the left and 1 standard deviation to the right, which is between mu minus sigma and mu plus sigma, so the probability of mu minus sigma less than x less than mu plus sigma is 68% or 0.68. So this is the property for any value of mu and sigma, provided that the mu and sigma abide by a normal distribution. Now the same rule also applies for 2 sigma, and so p of mu minus sigma less than x less than mu plus sigma is equal to 0.68 or 68%. So p of what is 2 sigma, 2 times the normal distribution, 2 times the standard deviation, mu plus 2 sigma is going to be 0.955%. And p of mu minus 3 sigma less than x less than mu plus 3 sigma is 0.997 or 99.7%. I'm sorry, this is 95.5%. So this is how we can, based on the standard deviation value. So these are the values. Now if you split it equally, because it's symmetrical across this axis, 68%, generally 68.2%, can be split into 34.1 and 34.1 until 1 sigma. From between 1 sigma and 2 sigma, the value is 13.6%. Between 2 and 3 sigma, that is 2.1%. Anything above minus 3 sigma is 0.1%. So these are the values that you can remember on your hand. So between mu plus, so this is the main part that you have to remember by heart, because most USMLE problems, if they give you a value like this, they would generally mention it based on the values of mu and sigma. So it makes it easier to write down these values. Next, last characteristic is the normal distribution is completely determined by the two parameters, mean and standard deviation. So for the entirety of normal distribution, you just need to know the mean and the standard deviation. So with that two values, you can represent the entire normal distribution. Now let's take a look at this diagram. So this value shows different means, so mu1, mu2 and mu3. So because their height is the same, they have the same sigma. So sigma 1 is equal to sigma 2 equal to sigma 3. So the height represents the sigma value and the center represents the mean. Now notice in this problem, all of them have the same mean, but notice the height. So the higher the peak, the smaller the sigma value. So as the height increases, the sigma value will decrease. So this is the relationship between height and the value. So here mu represents location parameter, where is it located, and sigma represents the shape parameter, how is it shaped. So these are the two variables that determine the values. Now notice here mu1 and here mu2 is here, so mu1 is less than mu2 here. Sigma 1 is lot higher and sigma 2 is smaller, so sigma 1 is less than sigma 2. So this is how we compare when you have two curves of normal distributions. Now let's take a look at the next one of how to standardize this normal distribution. So the way to standardize this is to take what is a standard normal distribution. Is a standard normal distribution is where the mean is 0 and the standard deviation is 1. So to find any probability, we basically find the area under the appropriate normal distribution curve. So for this, what we generally do is we note down the z-score. So the z-score is the value that can tell you how much the probability is. So when you take the z-score, so the z-score here represents the z distribution, is the value that represents the standard normal distribution. So how do you find this z-score? Is z value here is given by the formula x minus mu by sigma. This is the formula we use to convert a normal distribution into a standard normal distribution. So this is how we can convert a normal distribution into a standard normal distribution. Why do we need to convert it into a standard? So that we don't need to use this formula to calculate every single time. So the z-score value, or the standardized value, is basically tells you how many standard deviations below or above the mean the original value is. So it basically says whether the value is 1 standard deviation away or 2 standard deviations away. What does that mean? So if you take the probability of -1 less than z less than 1, that value is equal to 0.68. If you take the probability of -2 less than -2 less than z less than 2, that value is 0.955. And if you take the probability of -3 less than z less than 3, that is 0.997. Notice the values are exactly similar to what we did before, because z-score, standardizing the z-score using a z-score can help us find probabilities much more easily rather than using the formula every single time. Now let's try and understand how to find. So what are the properties of the standard normal distribution? So the first property is that the mean is 0 and the standard deviation is 1. And when x is equal to mu, then the z value becomes 0. So which means that z equal to 0 is the line that is symmetric. So if you take the distribution here, so this is z equal to 0. Any value to the less one is z is negative, left is negative, anything to the right is positive. But the total area under the curve is still 1, and each side represents 0.5. So each side represents 50% of the probability of the total function. Now let's take some examples and let's try and see how do you convert a transformation from one system into the other. So how do you convert a general distribution or a general normal distribution into a standardized normal distribution is by using the z value. So what we do here is we take x1 value and we find out the z1 value, which will be equal to x1 minus mu by sigma. In the same way, we take the x2 value and we find z2, which is going to be x2 minus mu by sigma. So by converting x1 to z1, we are basically converting it from normal to a standard normal distribution. So the reason we do this is because standard normal distribution has a specific table which can help us in finding out the probabilities much more easily. Now, how do you find in a graph? So how do you calculate from the table between a less than x less than b? So the formula for that is p of x less than b, where b is the greater one, minus p of x less than a. So remember this formula, because we are going to use this again and again. So let me write the set of formulas that we are going to use. So p of x less than a is directly found under p of z less than some value of z1. Let's call it z1. Next, p of x. So for example, p of x1 less than x less than x2 is found as p of z1 less than z less than z2. This can be written as p of z less than z2 minus p of z less than z1. So this is how we find it from the table. If you want to find greater than value, so x greater than x1, so we find it as p of z greater than z1. So we cannot find this directly from the table. So what we do here is we write it as 1 minus p of z less than z1. So these are the three set of formulas that we're going to use in this chapter when we do the problem. So remember these set of formulas. Now, so to find the values of the probabilities, we use the standard distribution table, the normal distribution table. So this is the table. In this table, if you look at the first row, so the first row contains, so the first column contains the z values. So these are all the z values that you have. So these are all the z values. And on the column part, we notice you have the decimal, the second decimal, which means that, for example, if I want to find minus 2.56, I'm going to take minus 2.5. In that, I'm going to find 0.06, and that value is my answer. So this is the value for minus 2.56. So you're basically finding until the first decimal, and the second decimal is the next row. So always take the values until two decimals so that it becomes easier to find the value. Now let's try and do a problem. So given the standard normal distribution, find the area under the curve above the z-axis between z equal to negative infinity and z equal to 2. Now let's try this problem. So they are asking you between minus infinity and 2. So which basically means they are asking you to find z less than 2. Nothing else. They are not asking you anything else. How would you find it from the table? So let me find the table first. So what you see here is an example of a standard normal distribution table. Now we have to find the value for z less than 2. So in the normal distribution table, we have to find the value for 2. So this is the value. So notice the z column here and notice the second decimal column here. We have to find for 2. So this is the value 2. And I'm going to find it for 0.00. So 2.00. So this is the value. Now 0.97725. So when you write it down, so this is the answer, 0.97725, or you can write it as 97.725%. So this is the probability of value z less than 2. Now in the same way, let's try and find z greater than 2. How would you find z greater than 2? Notice that in the probability table, all the values are written in such a way that the probability that you find is z less than or equal to z. So which means that if you take z less than 2, so what we are doing here is that if you take this distribution here, when we take the value for 2, so when you take z equal to 2, so we are finding this entire probability here. So the table basically considers that if you take any z value, so if this is the z value, what is the value that you are finding is this entire probability, this entire area. Now if I want to find z greater than 2, so then you are finding this area here, this part here. How would you find that here? So that you would write it as 1 minus p of z less than 2. Remember the formulas I told you about. So the formulas that I told you about. So use the formula here. When you write greater than, write it as 1 minus p of z less than. So how would you find it here? 1 minus z less than 2. The value is 0.97725. So 0.97725. So use a calculator. So the value is 1 minus 0.97725. So that value becomes 0.02275 or 2.275%. So this is the value of p of z greater than 2. Now in the same case, let's say if I want to find something else, let's say they're asking you to find the probability between z equal to minus 2.55 and z equal to 2.55. So how would you find it in the table now? So first thing first, always draw the diagram so that it becomes easier to understand the topic. So this is the distribution. Let's consider that this value is minus 2.55 and this is 2.55. So they are asking us to find the area of this area. How would you find it from the table? So you can write it as p of minus 2.55 less than z less than 2.55. So how will you find this from the table? Remember the formula. So P of Z1 less than Z less than Z2 can be written as P of Z less than Z2 minus P of Z less than Z1. So P of here Z less than 2.55 minus P of Z less than minus 2.55. So first things first, we want to find 2.55. What is the value? So the first value is 2.5 and 2.55 is this row. So that row is gonna be 0.99461. So write down the value. So that is 0.99461. This is the value for Z less than 2.55. Now we want to find Z equals minus 2.55. So we have minus 2.5 and we have to find 0.05 under this again. So this is 0.05. So under that you have 0.00539 minus 0.00539. Now subtract the two values. You have 0.99461 minus 0.00539. So that gives you a value of 0.98922, or we can write it as 98.922%. So this is the probability between minus 2.55 less than Z less than 2.55. Now in the same problem, try to find P of minus 2.46 less than Z less than 2.46. So I'm going to attach the table with the problem. So in the canvas, so make sure you download the table first and keep it on your computer so that when practicing it becomes easier. So try this problem now, and if that is done, try Z less than 3.21 and also find Z greater than 3.01. So pause the video right here and try to solve these problems. So if you're done with the last example, so pause the video right here and try to solve these problems. So let's recap how to find the Z values. So when you have P of Z less than A or P of Z less than or equal to A, so just find the table and for the Z value find probability. Alright, so that's it directly. But if you have Z greater than A or P of Z, so let me write it as B here so that it becomes separate. So or Z greater than or equal to B, how will you write this formulas? Both of them are the same. So the formula is 1 minus P of Z less than B. Right, so find now the probability for B and calculate probability and substitute it into this value and finally find the answer. If you have two values, A less than Z less than B, then the formula is P of Z less than B minus P of Z less than A. So find the probability for B and find the probability for A and finally find your answer. So these are the two main formulas to remember. So this is one formula and this is the other formula. So remember these two formulas, it makes it easier to understand the problem. Now let's come to normal distribution application problems. How do you apply normal distribution to the problems? So we use the following steps to solve normal distribution problems. First, write down the data that you have in the problem. Second, sketch a normal distribution curve. And third, convert x to a z-score using the formula z equal to x minus mu by sigma. And fourth, sketch the standard distribution curve. And finally 5, find the values from the table, and 6, complete the answer. So these are the steps that are required while solving the problem. Now let's take a problem and let's see if we can solve this problem. So a certain storage battery, so let me write it down separately. So now let's try and solve this problem. So first thing we want to do is note down the data. So in the problem it's given that a certain type of storage battery lasts on an average 3 years with a standard deviation of 0.5 year. Assuming that the battery life is normally distributed, given that the battery will have less than 2.3 years, find the probability. So the first thing is mu. So the value for mu is given as 3 years. So note down 3 years. And the standard deviation sigma is 0.5 years. And they are asking you for the probability that the battery will last less than 2.3 years. So the probability of x less than 2.3. So this is the probability that they are asking for. So if you draw the normal curve now, you notice that this is the mu value, which is 3.0, and the standard deviation here sigma is 0.5, and they're asking you to find the probability of 2.3. So for example, let's consider that this is somewhere 2.3, so they're asking you to find this area. So to find this, first we need to convert it into the z score. So the z score formula is z equal to x minus mu by sigma. So x is 2.3 minus 3.0 by sigma is 0.5. So that becomes minus 0.7 by 0.5. So that becomes minus 0.14. So this is the value for the problem. So you can check it. So 0.7 over 0.4, 0.5 is 1.4, I'm sorry, minus 1.4. So this is the value of z. So now we can convert this p of x less than 2.3 into p of z less than minus 1.4. Now we are finding the probability of z less than minus 1.4. How will you find this? So let's go to the table back again. Minus 1.4. So this is minus 1.4 and 0.00. So minus 1.40 total. So this is the value 0.08076. Right. So this is the value 0.08076. Now 0.08076. So in percentage, if you want to write it, divide this by 100. So you get 8.076%. So which means that the probability of x less than 2.3 years is 8.076% or 0.0876. So this is how you can convert the problem from one value to the other value. So if you draw it in terms of the standard normal distribution, so this is the z value equal to 0, this is the z value that you have 1.4, I'm sorry, minus 1.4, and this is the area that you found as this problem. So this is how we can convert and apply normal distribution into the general problems. Let's try another problem. Now let's try this problem here. What is the given here? So 800. So 800 is the value of mu. Standard deviation is 40. They are asking you to find between 778 and 834. So write down the data first. Mu is 800. Sigma is 40. And they are asking you for probability of 778 less than x less than 834. So which can be written as the probability of x less than 834. So the first things first, let's try to convert. So you have two z values. So this is x1 and this is x2. So first find z1. So z1 is x1 minus mu by sigma. x1 is 778 minus 800 by 40. Z2 is x2 minus mu by sigma. So which is going to be 834 minus 800 by 40. So 778 minus 800 will give you 22 by 40 for Z1, and Z2 is 34 by 40. Sorry, this is negative 22 by 40. So when you calculate 22 by 40, so the value is minus 0.55. So for 34 by 40, so that value is 0.85. So now write it down in terms of Z. So the probability of Z1 less than Z less than Z2. So the probability of Z1 is minus 0.55 less than Z less than 0.85. So this is the probability that you're finding. So now let's note this down on a separate page. So probability of minus 0.55 less than Z less than 0.85. So this can be written as probability of, remember A less than Z less than B, so Z less than B first, so Z less than 0.85 minus the probability of Z less than minus 0.55. So probability of Z less than 0.85, again go back to the table. So we are finding for minus Z 0.85 first. So this is 0.85 first. So you have 0.8 here. So you have 0.8 here. We are finding 0.85. So this is 0.5. So 0.85 becomes 0.80234. So write it down. 0.80234 minus 0.55. So minus 0.5 and 55 is here. So in this one, so this is the value, minus 0.29118. Sorry, 29116. So 0.29116. So 0.80234 minus 0.29116, that gets you a value of 0.51118. So this is the probability of minus 0.55 less than Z less than 0.85. But this is not the original probability, right? The probability originally is 778 less than X less than 834. This value is 0.51118 or 51.118%. So this is how you can find the probability by applying conditions. So what is the data given? You have mu, which is 3.0, and sigma, which is 0.005. Now the bearing diameters that are given is 3.0 plus or minus 0.01 centimeters. So if you take the distribution table, if this is 3, so these are the two values. So if you write it as 3.0 minus 0.01, that gives you 2.99, and 3.0 plus 0.01, that gives you 3.01 centimeters. So this is 2.99 and 3.01. So this part is accepted. So which is rejected here? So these are the parts that are rejected. So this part is rejected and this part is rejected. So let me write down the probabilities that way. So we are finding two probabilities. One value is probability of Z less than 2.99, which represents this area, and probability of X less than 2.99, and this part, which is probability of X greater than 3.01. So you have two probabilities that we have to find, X less than 2.99 plus probability of X greater than 3.01. So first things first, convert these into Z values. So what will be the Z value for this? So Z becomes X minus mu by sigma, which is 2.99, minus mu is 3.0 by sigma is 0.005. So you have 2.99 minus 3 over 0.005. So that gives you a value of negative 2. Now for the second value for 3.01, so when you find it, you get 3.01 minus 3.0 by 0.005. So that is 0.01 by 0.005. That becomes 2. So when you write it down as the probabilities, so the probability of X less than 2.99 becomes z less than -2 plus the probability of z greater than 2. So we know the probability of z greater than -2 that you can calculate directly from the table, but z greater than 2 becomes 1 minus p of z less than 2. Now, how would you find this? So because this value in general, if you actually find out the value, you will notice that this value actually becomes nearly equal to 1. So which is something that we don't want to do. So what we can do now, rather than doing this, is notice that these are the two values. So this part is accepted, so which means that anything other than that is rejected. So for this value, what we can do now is we are finding the exact same z values. We have found the exact same z values, but rather than finding it this way, let's find p of 2.99 less than x less than 3.01. So this value for this z value is -2. Again, for that z value it's 2. So that probability is p of z -2 less than z less than 2. So if you already remember from the table, you can find the formula directly as p of z less than 2 minus p of z less than -2. So from the table, what is the value for 2? So the value for 2 is 0.97725, 0.97725 minus for -2. So for -2, the value is 0.02275, 0.02275. So that value is going to be, so let's find out the value, 0.97725 minus 0.02275. So that gives you 0.9545. So this is the probability of -2 less than z less than 2. So this part is the accepted part. What is the rejected part then? So rejected is 1 minus accepted. So 1 minus 0.9545 becomes 0.0455, or we can write it as 4.55%. So this is the amount that will end up being rejected. So this is one another way for finding the same answer, but using one another method. But the answer is still the same. So you are finding the exact answers being the same. So this is how you can apply problems for normal distribution. Now pause the video right here and try to find this problem. So here this is the value of mean and this is the standard deviation, and they are asking you for less than 3 hours. So p of x less than 3. So try to convert it into z value and then find the probability. So pause the video right here and try to solve this problem. So in the same way, try this problem as well. So if done, pause the video right here and try to solve this problem. So pause the video right here and try to solve this problem.